Hello everyone, welcome to the channel Learn Math with Shobita. Today I am discussing another question from 2015 KSET. The question is about which of the following series is convergent. So the first series is given by 2n series 2n plus 5 by 3n plus 1. Here un is equal to 2n plus 5 by 3n plus 1. Limit n tending to infinity of un. You will get limit n tending to infinity if I take n. Then 2 plus 5 by n divided by 3 plus 1 by n. So which is equal to 2 by 3, not equal to 0. So therefore by nth term test series un is divergent. Next they have given the series 1 into 3 into 5 into and so on into 2n minus 1 divided by 2 into 4 into 6 into and so on into 2n whole to the power square. Okay. So here we will apply the ratio test. Here un is equal to 1 square into 3 square into 5 square and so on into 2n minus 1 whole square divided by 2 square into 4 square into 6 square and so on 2n whole square. So un plus 1 will be 1 square into 3 square and so on 2n minus 1 whole square into 2n plus 1 whole square divided by 2 square into 4 square into 6 square and 2n square into 2n plus 2 whole square. Therefore un by un plus 1 will be equal to cancelling the common terms, you will get this as 2n plus 2 whole square divided by 2n plus 1 whole square. Okay, so this term divided by this term, cancelling the common terms, you will get 2n plus 2 whole square divided by 2n plus 1 whole square. So taking 4n square outside, you will get the ratio is equal to 1. Limit n tending to infinity of un by un plus 1 is equal to 1. Therefore, ratio test fails. So, according to ratio test, if series un limit n tending to infinity of un by un plus 1 if equal to L which is equal to 1, then the ratio test fails. So, if ratio test fails, we can apply the Rabe test. According to Rabe test, un is a series of positive terms, limit n tending to infinity of n into un by un plus 1 minus 1. So let us apply that Rabe test. So if you apply Rabe test n into un by un plus 1 minus 1, you will get this as this. So if you want, please pause the video and make the calculation yourself. So while Rabe test also you got the limit as 1. So Rabe test also fails as n tends to infinity. The limit you will get 1. So Rabe test fails. Next we will apply the Gauss test. Okay. So here un by un plus 1 is, we got 1 plus 1 by n square into 1 plus 1 by 2n to the power minus 2. So when we apply the Gauss test is applied if we expand un by un plus 1 in terms of power of 1 by n. So here we can expand using power of 1 by n. So expanding it, you will get this as 1 plus 1 by n plus order of 1 by n square. Comparing it with the un by un plus 1 is equal to 1 plus lambda by n plus order of 1 by n square. So here we have lambda is equal to 1. Therefore, by Gauss test, series un diverges. So what is Gauss test? I have already discussed Gauss test. Okay. So Gauss test is, I will test. Where is Gauss test? Here it is. If series un is a series of positive terms such that un by un plus 1 is equal to 1 plus lambda by n and some terms, then series un is convergent if lambda greater than 1 and un is divergent if lambda less than or equal to 1. So here series un, here lambda equal to 1, so series un diverges. Please see the real analysis session about infinite series. In that I have explained all the tests. Okay. Next term is series n equal to 1 to infinity 1 by n to the power n plus 1 by n. So let us apply Cauchy's root test here. Whenever some powers of n comes, we have to apply the root test. So here an to the power 1 by n, you will get 1 by n to the power n plus 1 by n to the power 1 by n. So here you will get 1 by n into n to the power 1 by n square. Okay. So now limit n tending to infinity of 1 by n into n to the power 1 by n square. So let us evaluate the limit n tending to infinity of 1 by n to the power n to the power 1 by n square. So let y is equal to n to the power 1 by n square. Then ln y will be equal to 1 by n square into ln n. Limit n tending to infinity of ln y, we will get limit n tending to infinity of ln n by n square. Here we cannot directly apply n s infinity. You will get infinity by infinity form, which is undetermined form. So apply the L'Hopital's rule. Applying L'Hopital's rule, derivative of ln n is 1 by n, and derivative of n square is 2n. So here you will get limit as 0. So ln L is equal to 0. Therefore L is equal to e power 0, which is equal to 1. Limit n tending to infinity of en to the power 1 by n, you will get it is 0. Applying this, therefore, which is less than 1, therefore series an converges by root test. Next, option D, series n equal to 2 to infinity 1 by log n to the power log n. So let us see how to solve it. Since limit n tending to infinity of log n equal to infinity, we can find n so large that log n is greater than 2. Multiplying log n both side, log n into log n greater than 2 log n. Now applying the properties of log, that is a log b is equal to log of b power a. Applying that property, we get log n to the power log n greater than log n square. So log n to the, now cancelling log on both sides, taking exponential, we get log n to the power log n is greater than 1 by n square. So which implies 1 by log n to the power log n is less than 1 by n square. Okay, this is true for all n greater than or equal to 2. So since series 1 by n square converges, this is because this is a p series with b equal to 2. By direct comparison test, series 1 by log n to the power log n converges. So here in this question, we got two series which are convergent. One is series option C is convergent, also option D are convergent. Both the series are converges. Thank you friends. Please share and subscribe the channel.